Hi guys, today I'm going to talk about integration by substitution but of a definite integral. Is it different? Actually it's not different at all. The only difference that if you have boundaries here, would that make any difference? Actually it's only a small difference in a way of writing, not in solving. So let's go through this example and try to do it. This is multiplication and not simple multiplication, so I have to choose u, and u in this case would be what's inside the composite, so 2x to the power 4 plus 1 du over dx equals 8x cubed, so dx equals du over 8x cubed. As usual, you have to put this into your integration, so it's x cubed times u squared times du over 8x cubed. Now, why did I leave the boundaries here? Actually, this is the only difference that you have to take care of. These are values of x, the 0 and the 1 are values of x. And now you are having u inside your integration. So you have to keep writing here when x equals 0 and when x equals 1 until you get rid of the u or the x. So you have to take care of this. So what's going to happen here after you simplify? This will be integration of, 1 over 8 outside, u squared du. Now you have the option either to keep writing x equals until you reach to the end and replace u, or you can replace the values of x by values of u. How to do that? That's simple. As usual, when x equals 0, u from here will be equal to 0 to the power 4, 0 times 2, that's 0 plus 1, so u will be equal to 1. So I replace 0 for x by 1 for u. When x equals 1, u will be equal to 1 to the power of 4, that's 1, times 2, that's 2, plus 1, u equals 3. So you can replace your boundaries for u. That's an option. So you can write it from 1 to 3. That's up to you. If you want to keep it in x, that's fine. If you want to deal with u immediately, that's also fine. So this will be 1 over 8 times u cubed over 3 from 1 to 3. You substitute now by definite integral, so 3 to the power of 3, that's 27 over 24 minus 1 over 24, which will be 26 over 24. Of course, that can be simplified, so 13 over 12. So what's the other choice? The other choice is to move from here, from this step after you did substitute, after you finish substitution, so it will be u cubed over 24 from x equals 0 to x equals 1. You have to keep writing this until you replace the u, and u was 2x to the power 4 plus 1, so this will be 2x to the power 4 plus 1 all cubed over 24 from 0 to 1. Now I can remove the x because it's all x, which is when you substitute you will get the same thing, 27 over 24 minus 1 over 24, and that would be 13 over 12. Same thing. And that's the only difference, so you have to keep this in your mind when you are dealing with definite. You are talking about values of x, so either replace them with values of u, or you just keep them as values of x, but keep writing x equal at every boundary. Let's have a look at another example, just to remind you of a few other things. Let's say I wanted to integrate 1 over x ln x. We did this before, from e to e squared. Okay, let's do this again by substitution. Since we have ln, so u should be the ln du over dx Derivative of len is derivative of what's inside over what's inside. Cross multiply, dx is equal to x du. Now your integration will be 1 over x times u, x du, when x equals e to x equal e squared. These can be simplified. So now you have u and values of x, and again you have the choice. For me, I prefer to convert these. So when x equals e, u will be equal to len e. Len e is 1. When x equals e squared, u will be equal len e squared, which is 2. So I'm going to use 1 and 2 instead of e and e squared. That will make the solution looks better. So integration 1 over u du from 1 to 2, which is len absolute value of u from 1 to 2. So it's len 2 minus len 1, and len 1 is equal to 0. So the answer is len 2 immediately. I hope that this idea is clear. It's nothing new, it's just the boundaries. So try to do this by your own.